Hello and welcome to my lecture series for Control System 1. Myself, Shuman Ghosh, as a course coordinator, assistant professor from Department of Electrical Engineering, Guru Nanak Institute of Technology, Kolkata. And this lecture series is for Control System 1 and which is basically for 5th semester BTech Electrical Engineering students. And here is the course, and the name of the course is Control System 1 and the code of the course is EE503 and total contact hour per week is 3 and the total lectures for the semester is 36 hours and the credit of the course is 3 and this is the prerequisite and these are the course outcome. And here is the course content, where is in module 1 there is introduction to control system, and in module 2 there is mathematical modeling of dynamic systems, and then control system components, and then we go to time domain analysis and we analyze the stability of a system by using Root-Lucas method, and then we goes to frequency domain analysis, and then there will be some control system performance analysis by using lead lag compensator, and some case studies will be there. And here is some textbooks you can follow, that is Ogata, Modern Control System by Ogata, and Control System Engineering by Nagraj Gopal, and Control System Engineering by D. Roy Choudhury, and Automatic Control System by B.C. Kuo. And here is some reference book that you can follow. So, here is the introduction to control system, that is the first module, where the concept of feedback and automatic control is there, and the types and example of the feedback control system will be there, and transfer function and poles and zeros will be there. So before starting, here is some definitions which you have to know for better understanding the control system. Now, before starting the control system, the subject name is control system. So what is control and what is system? So first of all, what is system? So here a system is basically combination of components. That components may be physical, biological or economical. So it's basically a combination of all types of components. So that's a system. And control system means that components which is in the systems that can be controllable. That is, here the definition is, it is an arrangement of physical components connected or related in a manner to command, direct or regulate itself or another system. So basically the components of system can be controlled. That control may be automatic or maybe human control or manual control. That's the other thing. And next, what is input? Input of a system means the input is the excitation. Input is basically excitation that is applied to a system. That is basically input. And output is basically the response that we get from the system. That is basically the input. And the plant or process. In many places you can see that that is right, plant or process. So the plant or process is basically the control system Body plant is the control system body, process or machine of which a particular quantity or condition is to be controlled. So that is basically the plant. And next is the linear control system and non-linear control system. So what is the linear and non-linear? First of all, we have to know what is linear system and what is non-linear system. We all know superpositions theorem. Okay, superpositions theorem. So what is superpositions theorem? Suppose for input x1t the output is y1t, and for input x2t the output is y2t, and if we give two input at one time, that is x1t plus x2t, then the output will be y1t and y2t. So if we add the input signals, then the output will be added. So this property is basically additive property. And what is homogeneity property? If we multiply a with x1, then the output will be multiplied by a. That is, if the input is x1 and the output is y1, then we multiply a with x1, that is ax1. If the input is ax1, then the output will be ay1. So that is homogeneity property. And if a system has both additive property and homogeneity property, then the system is called linear system, that is linear control system. So a system which obeys the superposition principle, that is called linear control system. And other way, if the system is not satisfy or not obey superposition theorem, then the system is called non-linear system. So here the another thing is what is continuous time and what is discrete time. Now continuous time control system, where performance of its parameters are the functions of time, where the parameters are the functions of time. That means for example, armature type speed control system, that is a continuous time, and discrete, where the parameters are the functions of discrete time. And next, what is SISO and what is MIMO? SISO stands for single input single output, where in a system there is only one input and one output, that is single input and single output system. And MIMO system, that is multiple input and multiple output. So this is basically SISO and MIMO system. Now in our syllabus there is a topic, that is concept of feedback and automatic control. Now what is the feedback control and what is automatic control? Now before starting feedback control and automatic control, we have to know what is open loop control and what is closed loop control. Let us take one example, that is room temperature control. Suppose we want to control the temperature of a room by using a room heater. Okay, so first, so this can be controlled by the temperature of the room. As simply, the temperature of the room is controlled by switching on or switching off of the power supply of the heating element. That means the heater. By using heater on and heater off, we can adjust the room temperature. Now, thus the power supply to the appliances is switched on if the room temperature is felt low. If the room temperature is low, then we put on the switch and the room temperature is high, then we switched off the temperature. That is one process. There is no control of the that means in this case the output has no control on the input. That means the output temperature has no control to the input temperature or the heating element unit. Okay, so this is a open loop type control system. Just see the figure which is shown here. The input is RT and the controller means here the heater. Here the heater is the controller that controls the room temperature, and next is plant. Plant is basically the room. Here plant is basically the room which temperature we want to control. So controller means the heater. By switching on and off, we can control the room temperature, that is plant. So here no, and the output, here the output is CT. So here no control. So here the output has no control on the input. Okay, so this is a example of open loop control system. Another example is traffic light signal control, washing machine, bread toaster. This is all open loop control system. Now, what is closed loop control system? Now, suppose that room temperature, that the actual room temperature is the output temperature. Now, by using a sensor or any other measuring instrument, we can measure or sense the room temperature. Now, the we sense the room temperature, actual room temperature. Now, the difference between the actual room temperature and the desired means which temperature we want for the room. So that is the desired temperature. So difference between actual room temperature and the desired room temperature is basically the error signal, or basically the error signal. So if the error signal is given to the controller and on the basis of the error signal the temperature can be controlled, that type of system is called closed loop control system. That means the output, the output has a effect, output has controlled the input. So that is the closed loop control system, which is used in air condition or air conditioning system in your home. So here one example is there where desired temperature is actually the input RT and the output is the actual room temperature, that is the output CT, and the feedback, hence one feedback. Feedback means the part of output which is given back to input, that is the feedback. The part of output that which is given back to the input, that is feedback. Here feedback signal is BT. The difference between input or desired signal and the output signal is called error signal, which is given in the figure as ET, that is the error signal. That error signal goes to a controller which controls the signal, which controls the temperature. Okay, so that is the controller. In AC there is a controller which controls the temperature, and then it goes to the plant or process means the room. Actually here in this example, in our example, that is room temperature control, here the plant or process is the room, actual room. So this is basically a closed loop control system. In closed loop control system there will be a feedback, there will be a feedback element or a feedback path. Okay, and there will be an error signal. So this is basically closed loop control system. Another example of closed loop control system is automatic iron, automatic electric iron, missile launcher, speed control of DC motor, etc. So these are the closed loop control system. Okay, and here and coming to the next slides, and the next slide is comparison between open loop and closed loop control system. Now what is the difference? Now we all know what is the difference, what is open loop control system and what is the closed loop control system. Okay, before starting the difference, there will be a term, there is another term, that is automatic control system. Okay, now what is now concept of feedback and automatic control, we all know what is feedback. Feedback means the element which comes from the output and goes back to the input, so that is the feedback. Now what is automatic control system? In automatic, now the control system without involving human interventions or manual interventions for normal operation of the system, that is called automatic control system. Automatic control system, that is air conditioning system is automatic control system. Now traffic light control, the three light control which we can show in traffic signal, that is basically a automatic control system. Okay, now going to our slides, that is difference between open loop and closed loop control system. Now in open loop control system there is no feedback element. We all know there is no feedback control system, no feedback path, rather feedback element. And in closed loop control system there will be a feedback element or a feedback path. Okay, now in open loop control system the output will not vary. The output will not vary for a constant input, where in closed loop control system the output may vary for the constant input due to that error signal. And error signal, from where the error signal comes, and the error signal is basically the difference between desired and actual value. Okay, so in closed loop there will be no error detection is there, and closed loop there will be error detection. So there is another more difference, just go through. So basic difference is between open loop and closed loop is the feedback element. Okay, so next is transfer function. So for this for today's lecture 1. For lecture 1, that's for lecture 1, and in lecture 2 we continue with transfer functions and pole zeros problem, etc. Okay, thank you so much.